All right, welcome everyone. This is the February 26th, 2024 community meeting for Karpenter. As a way to start off, we'll start off with some project updates. So these are the project updates that we've had for the past couple weeks as well, or the past couple of meetings. So the first one is the path to V1. We're still keeping this in the project updates just because anyone who wants to add on to the Kubernetes SIG's Karpenter V1 laundry list or the Avis Karpenter V1 laundry list, or the Microsoft V1 laundry list. If I'm not sure if Microsoft has one, but we'll keep these here. And if you have some things you want to see in the V1 APIs, we're currently thinking about how we're going to tackle all the items in the laundry list. So feel free to check these out and add some comments as you please. At core, there's going to be some observability improvements that we want to make. I know that Garvin has added some mega issue on some observability improvements with regard to logging and metrics. But we're looking at tackling some other things like adding status conditions to all the custom resources as well. And then the last one is that we're going to remove any blocking dependencies on dependencies that we took early in the project that may not have the same compatibility guarantees into the future that we need. Cool. Moving on to the Karpenter CAPI working group. You want to go ahead, Michael?
Thanks, Nick. Yeah, so quick update. I think we have an alpha design that we're happy with in the CAPI community at this point. And that kind of all came together, I think, last week. We had a bunch of just different conversations with CAPI folks. So I'm feeling pretty confident about that. And we're working towards making a proof of concept around this now. I think the repo will probably hold off on creating the repo until we have the proof of concept in a state where you can like build something and try it out. So it'd probably be a few more weeks before we get the repo in place. But making good progress so far, and I think we won't. The initial versions of this probably won't have like pricing information plumbed through from the CAPI side, but I think at the very least we'll be able to see like Karpenter operating on like instance sizes and kind of doing its normal behavior. My hope is that later on we'll come back and start to talk about how Cluster API exposes pricing information as well. So yeah, I'm excited, and hopefully we'll see how it goes.
Yeah, maybe when there's a little bit more progress, we can get some sort of demo in this working group too.
Yeah, I would love to. That'd be great.
Cool. All right, moving on. Unless there's any other project updates from any of the maintainers. Cool. Yeah. Okay. So next one, I added the this new section, the RFC, because I realized in some of our meetings we have a lot of RFCs that people want to just put out into the community and get some reviews on them. So if you have any RFCs for a meeting, you can start adding them here. Whether that's one that you think is whether it's like almost done being reviewed, or you just put it out there and you want to see if there's any validity to it. Yeah, feel free to add your RFCs here. We can start off with the drift hash versioning. Manuel, you want to go ahead?
Yeah, just hoping to get some more feedback, making updates as we go along with it. Main problem here that we're trying to tackle is of the fact that like during CRD upgrades, we can get into a state where Karpenter may drift all nodes that are currently in a cluster due to the fact that the underlying schema of the node pool has changed. And so we are trying to figure out ways, possible solutions to tackling this problem by either having Karpenter have some awareness of what the schema is, and then putting that into consideration while it's doing its normal drift operations. And so currently the leading idea is just annotating the CRD with a hash version in which we can propagate down to both the node pool and the node claims to prevent this happening. Ideally, we would like to have a solution that a cloud provider, like similar to the node pool, at least for for AWS, we have the same mechanism for the EC2 node class, and we would like to have a solution that works for both cloud provider as well as the Kubernetes 6 Karpenter. Yeah, and so that's kind of where it's at. If anybody would like to, well, if anybody has any questions now, I can, I can acknowledge and answer some of those questions, as well as you know, get some feedback. You can also add feedback as well. Yeah, Alice.
We can't hear you, Alice, if you're speaking or muted.
Okay. I guess while he figures that out, Garvin, you want to go, and then we can come
Yeah,
back.
I think the main concern I had was regarding the when the default changes when the CRD got updated. I don't think I feel super strongly, but I think that's something that should be brought up or addressed. Specifically, like, yeah, number one, where, oh, sorry, not number one, sorry. A field was added with a default. Yeah. I think the concern here was that, or a default change specifically around that, where, like, let's say I currently have a node pool or something, in the previous version where there's no default on a certain field and a new default was added to a field. My concern was that with this design right now is saying, hey, we're not going to drift when the CRD got upgraded. And my concern here is that, and I think I wrote this up here, is that on the issue was that, or sorry, the RFC was that in some ways I do eventually expect drift to supposed to happen because I know that behavior has changed because a new default is added. And right now the dog's saying, hey, don't drift. Only when you update the node pool, for example, that drift should happen, or some way of expiring as a way to get out of the old behavior to the new behavior. And I think there's some, at least from a user perspective, it's going to be very confusing because drift naturally exists to address the change in behavior as a way to, update or progressively roll out a behavior change, and not relying on that when defaults change seems weird to me because, like, I expect, hey, I'm on new CRD version. Yeah, there's a new default. My things should eventually behave like the new default. And I need some signal that says, hey, my stuff is in the old CRD version, but eventually it'll go away from that behavior to a new one. And it feels like drift is the right thing to do. And it feels wrong to me that we're not drifting on that. I guess I want to bring this up with the working group, see like what do people think. Like, at least from my perspective, that feels weird to me. And the behavior is inconsistent and it's slightly confusing. I mean, I'm happy to be wrong, but then that's my concern around that aspect.
Gotcha. No, I think that's a valid that's a valid concern, a valid thing. Yeah, that makes sense. I guess one thing I want to point out is of the fact that so within the node pool, I guess once a user has upgraded and there's a new default has been added, when Karpenter at least launches nodes or new node claims, they will have the default behavior, like
Right, the new default, yeah.
the new default. For the rest of the cluster, the idea here is to kind of give that sort of power to the user, whether they want all of their nodes to be rolled or whether they want to add a new budgets to how their nodes are going to be rolled. Because as soon as it's upgraded, their currency, all of their nodes will be drifted at that point. And for some, I mean, for some users that would be that could potentially be very aggressive.
Right, I guess from my perspective, like that's what drift and like the breakdown of the structured budget into, like, I guess methods of reason comes in, right? Like, it's true that all my nodes will get into a drifted state, but I guess first thing is that gives me a indicator which may not exist right now where something is going to change because there's behavior that's on this node pool that doesn't represent what the code or like the defaults that should be doing. So first, that's a signal to me that there's some behavior on these set of nodes or managed by this node pool that doesn't align with what Karpenter is going to expect. So first thing is that signal that tells them something's going to change. And second is that you're right, and that is part of the concern is that my entire clusters, all my nodes will be in a drifted state, but if we're not using node disruption budget as the way to drift or update the change, progressive level change, what else is there? I mean, like, short of a new budget completely and having that manage CRD updates, which feels weird, right? Like, how's that? Why is that not just drift? You know what I mean? Like, why add another disruption budget when drift kind of handled this? Maybe, I don't know if Bryce is here, but then adding additional drift reasons, because within drift there is sub reasons, and right now obviously doesn't support that, but like we can add support for like drift due to version upgrade, which we know is more disruptive, and using that as the mechanism for updating rather than completely something else, because drift is something that everyone kind of knows about, but CRD upgrade is having it separate seems weird for it to be completely separate, if that makes sense.
Okay. So, I mean, I guess the kind of sum up the point that you're trying to get at here is to just kind of like let it happen. Like if the entire, like if these kind of changes in certain cases, well, like, well, for the other cases of like letting, the other cases of having, well, I guess, are you trying to also say like, do you think this is also valid for what if new field is added with a default?
New
Is-
field is added. No, well, new field added. That feels weird to me. Like with a default, I think to some degree that's true too. In that, like, if I'm not using that field previously and then a new one is added with a default in there and it changes my behavior, then yeah, I agree. Like, if
It
a new
depends
field is
on-
added, no default, then it doesn't matter to me. But if a new field is added with a new default, that means a new behavior, then yeah, I think it should fall into drift.
Okay, so a field, so anything that has defaults or changes defaults should you're saying the expectation should be to just let that be carried out.
Through drift, I think like it's not even default, it's like a behavior change. Like I currently have a set of parameters that I set the behaviors to be. If you introduce something that changes the behavior on my notes, it should fall into drift. That's because drift is the mechanism right now to change like configurations of a node and its behaviors in a progressive way that that like kind of encapsulate all the other stuff that drift is dealing with right now. And to me, that makes it easier to track and deal with rather than a brand new thing that's similar to drift, but then I'm gonna get confused, or like new people will be like, what is the other thing? Why is it separate from drift? Like it can be a new category within drift. It just feels like drift already exists to deal with changes in my definition of CRD, which means behaviors, and this feels like that too, and it feels right to be in drift. Yeah.
Okay. That makes a lot of sense.
Yeah,
Okay.
there's one thing we were considering, I think in a previous talk, was that if the node claim was already drifted prior to the CRD upgrade, that we just wouldn't touch it, that we would just let it stay drifted. So I guess in this case, if the node pool hash version wasn't the same hash version, then we wouldn't update any sort of hashing. I think it's a slightly different concept than like qualifying what the difference is in the COD upgrade, but the way we've taken it, at least in this version as I understand it, is that if it's changed at all, is that we'll propagate the default through the cube builder CRD defaulting and just let it happen.
Cool.
Just to jump in on sorry, I got my mic working now. The question was like we looked at how, I think I'd asked Jonathan to look at how replica set does like tracking, because expanding the field is a general problem for anything, trying to reconcile anything. It struck me that Cappy does this too. Like essentially when a machine deployment creates machine set, and tell me if my understanding here is wrong, Michael, but when a machine deployment creates a machine set, we need to keep track of the spec that we tried to launch with. And if we expand the set of fields that are supported in the machine deployment, that hash will no longer be correct. That's the same problem, right, Emmanuel?
Yeah.
So how do we, so presumably there's something that solves this. To the point you made in chat of like, if something modifies the underlying machine deployment, I actually don't think that we want to fix that either. Like replica set doesn't fix that for pods. Karpenter doesn't like that kind of like back propagation. That actually prevents other integrations. Like I want to taint my node claim retroactively or something, and then that would drift. So I don't think we want that. But how do you do like the forward propagation detection?
Like propagate, I guess propagating the values down to the node, I guess the machines or the node claims in this case, the underlying owned.
So we hash the spec, and then we
Yeah.
drop the spec onto the owned resource.
Yeah.
And then we can detect when the parent changes, we produce a new hash, compare.
Yeah.
But when you expand the fields of the parent, tell me if I'm wrong. This is my understanding of this. When you change the fields of the parent, the hash changes, and so now you have a drift, even though there's no drift. And this would be true for replica set, machine deployment, Karpenter, any owned parent-child relationship has this problem of like expanding the spec. And I know replica set does this by like manually hashing all the fields and being like painstakingly doing every field manually, so as to like catch these edge cases manually. I guess it's like a custom hash implementation, which we could do too. But I was curious how Cappy does it.
I guess I'm not fully aware of how Cappy goes about it. Michael, maybe if you want to give some, I'm just more of aware of the situation of the replica set and
Yeah, I'm trying to look at the Cappy code real quickly just to see if I can glean this, and I don't like. So in the cluster API world, just to kind of bring in the for reference here, like you have a machine deployment, right? And that's like, you know, deployment for pods or whatever that relates to a replica set, and which relates to a machine, you know. So a machine deployment relates to a machine set, relates to a machine. The machine deployment has like an infrastructure reference, right? It references the type of machines that should be created. So for us, the infrastructure reference is almost like, you know, it's like the class or whatever, the instance class we wanted to make or something. And so if you were to change the infrastructure template, that would not necessarily dictate a change in the machine deployment. And that I think is where you're talking about, like that now the configuration for those machines has drifted, but you've got a bunch of them that are deployed that are not updated. And I can see that the machine deployment does try to reconcile the machines that are under it, but only to make sure that they're owned, not to make sure anything else is going on. So like it keeps an old copy of its own spec and the new copy, and it tries to compare those. So if there were a difference in the reference, right? Like if the reference changed, then it would re-roll out everything. And I think that's probably the way you would look at it as a user, right? Is like, if I make an infrastructure template for machine A, and later on I want to modify that, I shouldn't modify it. I should make machine A.1 and then migrate my machine deployment to use the new infrastructure template. And that would cause a rollout of everything. But I don't think it automatically detects that drift in Cappy.
It's a little different because Cappy has like 3 different pieces that are all working together to support the templates versus like the top level management resource, whereas we only have node pools for Karpenter.
And is there only one field in machine deployment that references a template? Like it's just a ref. There's no other fields.
There are 2. There's a reference to the infrastructure template, which is like the actual like machine spec stuff, and then there's a kube ADM template, which is all the case specific.
So you could like essentially assume that would never grow, which is a nice simplifying assumption.
Yeah,
like
in my 4 years of using Cappy, I don't think the machine deployment spec has ever changed.
Yeah, it's been pretty stable for a while.
Okay. Cool. I guess, does anybody else have anything? Cool. Yeah, if anybody else has time to provide any additional comment or feedback, that would be very much appreciated. Thanks for your time.
Great. Thanks, Emmanuel. All right, moving on to the OTCR and Karpenter. I think this is you, Corbin.
Yeah. I have I guess a PR or FC out for this. There isn't too much there. Just waiting for review and I guess, any concerns regarding this, but I don't think we have to discuss or anything because it's very AWS specific. I think it requires that someone maintainer to take a quick look over it and see. Just calling it out. Yeah.
Yeah, I can definitely take a look at this week. But yeah, I haven't looked at it
No worries.
since.
Thanks.
Cool. I guess we'll go to community questions now. Michael?
Yeah, so I've been doing some experimenting with Karpenter and OpenShift. You know, if I didn't make it clear before, I work for Red Hat, and we're interested in OpenShift. So I was in doing that though, I discovered something interesting about OpenShift and about Karpenter. One, OpenShift is using a Kubernetes.io prefixed label that it does not exist in the well-known labels. It might have existed way long ago in the well-known labels, but it certainly doesn't now. And so when I'm creating node pools to try and make workers that could attach to an OpenShift cluster, it's, you know, Karpenter is complaining because it says, oh, you're requesting me to put this Kubernetes.io prefixed label on here, but it's not one of the well-known labels. And I was just curious if there's ever been any thought about, you know, would there be like a way to, you know, kind of modify that, or could we add those labels? Or
Yeah, from my understanding, I know that the like at least Kubernetes.io / I think hostname is like the reason why we don't allow that prefix. What are some of the OpenShift labels that you use that require the Kubernetes.io?
well, the one specifically I'm looking at, it's called, we call it node-role.kubernetes.io. And then we put like /worker or /control plane or something like that. And I can see that in the well-known upstream labels, I think it's like kubeadm has a node-role.kubernetes.io /control plane or something, but it's not part of the well-known labels. It's all the way at the bottom or whatever, you know, it's or yeah, there you go,
So,
that one. But that's not the same as what we're using. We're using one that says like /worker. And these aren't even well-known Kubernetes labels. These are like well-known kubeadm labels. So it's even not part of the, you know, it's part of the second part of this or whatever. But so yeah, anyways, I didn't know, like, was there I guess like I'm being recorded here, but honestly, my feeling is that OpenShift should probably stop using this non-well-known label. But in light of that change, perhaps taking a while to propagate, would there be a way to, like, in Karpenter maybe specify some of these things, or like add a flag so we could explicitly say like stop being so tight about the Kubernetes IO namespace or something?
yeah, I need to think about what are some of the other well-known labels that have like the Kubernetes.io prefix. I can really only think about the host name at
Like the
this
zone
point.
labels and region labels, stuff like
Topology,
that,
yeah.
architecture type, you know, these kind of things, right?
Can,
Host name.
can
Yeah,
we make
sorry.
this like a public, like file scoped variable that you could just mutate if you wanted to add, like as your own provider, you could just reach into that package and append the
Yeah,
list.
yeah, that'd be perfect. Yeah, totally.
We've used that a lot, like as a escape hatch for cloud providers. It's one of the nice models actually about cloud providers owning their own main is you can just like reach all the way down and change anything you need to for constant
Yeah.
variables.
Yeah, absolutely. But yeah, being able to inject like a user provided list of, you know, okay labels, that'd be perfect for our use case.
I think you can probably do that today, Nick. Like if you want to crack open the well-known labels bit.
Yeah, we actually, yeah, I think the part that we do is that we hack into the like we YQ onto the CRD for some of the validations.
Well, you shouldn't even need to do that. I was thinking like,
Or like we specifically add in the rejection for the Kubernetes.io.
hmm.
Maybe that's just within AWS here. I know that, Emmanuel, you worked on this. Do you remember if this is in just if we YQ the rejections or if they're into the kube builder spec?
Yeah, so they should be in, they could potentially be in both. Um, Track, but
Yeah, like I
mainly,
feel like it was happening on webhook or something, because I was getting a rejection back on the command line when I tried to issue
The validations are the same. So if you have the webhooks enabled, you should also get those rejections as well.
Yeah, we did. We were running with the webhooks, and I'm pretty sure I was getting a rejection from the webhook right when I did the kubectl apply or whatever.
Yeah, like right now it looks like we have the instance type, region, OS, all that like hard coded in as something that you can include, whereas anything else that doesn't have that, it gets rejected.
Even if you remove this, you'll need to remove it from the CRD because it'll validate. But even after that, like if you'd have tried to use this label on a pod, I think maybe it would break as well. Like the whole scheduler. Here, I'll link the code. Maybe not on a pod, but like this restricted label domains thing is you could like trace where it's used in the code base, but it's gonna like I forget the exact behavior, but I suspect that you're gonna need to change that. Or
Yeah.
mutate that variable. Unless, Nick, I'm wrong, and that was only used for the old validation, and it's not actually enforced anywhere else in the code base. It's just enforced at validation time.
No, I think this is enforced at runtime.
It's kind of an interesting idea. Maybe we shouldn't enforce the runtime and just enforce it at validation time. But
yeah, it'd be interesting. I think it'd have to be some sort of like well-known labels or allowed labels that you'd inject, like you were talking about.
anyways, this is like a variable. You just mutate it. Like any of these, actually, you can mutate if you want to change at your own risk. But like any cloud provider could take any additional opinion.
Okay.
Yeah.
I guess like to the point about this being something that would be like configurable in more places than just like perhaps cluster API provider or whatever. Like, could I make an issue on the core Karpenter repo here to make this, request for a feature or something to allow us to specify this?
Yeah, totally. I think we could go into some of like the technical ways you could do it, or maybe ways we can't do it, at least with our current behavior.
Yeah, awesome. Thanks. Yeah, because this is like, although I'm working, cluster API provider is like kind of my main target right now, but we do have use cases for like the AWS and Azure providers as well. So it would be useful to be able to use this in more places.
Yeah.
Thanks. That's it for me.
Cool. Thanks, Michael. All right, Garvin, you got something about Carpenter performance?
Yeah, this isn't necessarily specific to just this, but I guess I have some question regarding like Karpenter and his performance. Like, coming as a user, like how do I optimize Karpenter to work well? Because we're looking to expand Karpenter's management, but then I guess like if you just search for performance on the issues, some of them are kind of concerning. And right now there's no guidance or anything regarding like, hey, you should break up your cluster into node pools or stuff like that, that maybe give you more consistent behavior. And then I guess generally look at the code. It doesn't feel like there's any obvious ways to partition your cluster or things like that around Karpenter that makes it like perform better or consistently across the board. And I guess I was sifting through the code and there's some things here that I pointed out, like very down to a low level, like concerning regarding what Karpenter is doing, but then I guess from a high level perspective, right? Like how should a user be thinking about performance? Like at what cluster size, and I guess like what kind of recommendation you should have for like how I should deal with many nodes, like thousands of nodes and maybe 10,000s of pods, right? And how would you tell people to, hey, at this certain size, don't use Affinity because we know Affinity is already slow and scheduler, but how does that perform in Karpenter? How does the topology constraint plays into it and pieces like that? There's generally no information at the docs or high level, like how you should kind of manage your cluster as you go in, and as you expand Karpenter's management of a cluster, like how should you think about how you do these things, if that makes sense?
Yeah, this is definitely something that we've heard before. I know that one of the things that we want to take up prior to V1 is getting some benchmarking in on all of the core components within Kubernetes 6 Karpenter. That was one of the main reasons why we also wanted to get the Quack stuff in, is so that we could test the main libraries like performance without any like cloud provider influence.
Mhm.
It's also a really tough question to ask or to say like what the expected performance is, because Karpenter's building off Kubernetes and it's a very complex system with a lot of different dimensions.
For sure.
And so I know that the you can always abide by like certain tenets of like topology spread constraints or preferred anti-affinity or just like anti-affinity in general. Those will also always just be harder to compute just due to the natural complexity of them.
Right. I guess not necessarily like raw data, like this is how I would conform, but then like it's like, hey, here, like I think the benchmark would be great. It's just that like it's a question of like, we use Quark, like we perfed it against this size cluster, this many pods, and here's how it performs. What happens if I add affinity? How bad is it if topology constrained? How bad it's if these nodes or these pods are big or small, or like how bad is it when I provision how many K of cores, how many K of memories, and how long it takes to consolidate? Like, that would be just having that data being transparent and how well it performs, and that's that kind of information, and like, oh, how many node pools kind of help shape, at least from my perspective, like how I should approach like dealing with node pools or stuff like that, or how I should be concerned if there's too many things spinning up, how well it'll perform. Like, so I have a general idea, because like, yeah, right now there's no information, and I agree, like having those benchmarks will be just helpful just in shaping how people think about like how they deal with it. I'm not sure if there's any like mega issues that tracks like in general, like how to show this information a little bit better. This is just the deprovisioning. It's very specific to deprovisioning. Maybe provisioning has some issues too, maybe, or like not necessarily issues, but just having some information around like how provisioning and deprovisioning, they're very asymmetrical, but like how do you think about the two in terms of performance? Yeah.
Yeah, there's a lot that we can add in here totally. I know that we've heard more about the speed. We've heard more complaints or like requests about either increasing the speed of deprovisioning or decreasing the speed of deprovisioning. It really depends on the size of the cluster and the size of exactly what the user expects. And so there's some people who've said that they want nodes to take longer than a minute to deprovision, and there's others who say that they want it to take just like almost instantaneously. And so I think the best way that we can kind of support users here is to give benchmarks with a lot of different dimensions. And I'm definitely trying to work on this and taking this up. So once I get some more information on that, we can totally work together on that as well to get some user information on what kind of benchmarks and dimensions you want to see out of the testing. In terms of like what to give you right now, I know that the first thing I can think of is that currently with consolidation, if you don't have expiration enabled, then it's less consistent ordering of how we consider nodes to be consolidatable. So if you want to be able to have nodes, I guess, more correctly consolidated, as in nodes that are older are more likely to get consolidated, then one example is to enable expiration alongside consolidation.
See, okay. I guess not necessarily a performance issue specifically, but I guess one addition to that is like, I see that we have single node consolidation and multi-node, but there's no explanation of when and why the two happens. That'd be good to have somewhere. Like, I think we just have a general like blurb about consolidation, but then there's no breakdown of the two, which I think behave quite differently, but would be good to know somewhere. Yeah.
By when you mean they happen, are you wondering about like the order in which they're considered, or
Not the
like
order, but
why they're like separated out into two in
yeah,
the first
yeah,
place?
yeah. I guess like I think I know why, but there's no doc or like here's exactly why.
Yeah, we can definitely add on to that as well. I think as we get more into like get more documentation figured out with like the docs neutrality stuff, I know that there's going to be also people are going to come in and say like, oh, this part of the docs isn't as fleshed out as it should be. And I think that's, that'll probably get figured out as well during there. And if you also have specific documentation gaps that you want to see, it would be great to see an issue for that. And we can, maybe someone in the community might want to take that up.
Cool.
Cool. All right. The next one, using block device mappings and instance store policy together.
Yep. Hey, folks. Yeah, we have few pods with high ephemeral storage request. Before instance store policy feature, we use block device mapping, and we just bumped the storage like 300 or something like this, it worked. But now we enabled a new feature, read 0. But now when we create the pods, like unschedulable pods, Karpenter is struggling to launch new instances. And there is a really weird situation where our block device mapping storage is 300 and instance store policy is like, 1 or 2 terabyte. But sometimes Karpenter think that new storage will have 200 or 90 gigabyte storage. I want to understand where this information comes from. It is not block device mapping, also not real storage, real local NVMe storage, but some magical number comes from somewhere. And yeah, after, I don't know, maybe 50 or 100 tries, Karpenter somehow works and decide to launch new host.
So if I understand that right, you said that your block device mappings is 300 gigabytes, and you said that it incorrectly said it was 280 or something like that.
When Karpenter decide to launch, not decide, actually launch the new instances, there's a log line like launched not claim, and there's a section allocatable. And in allocatable section, there is information about ephemeral storage. This information is not stable. So for same region, same instance types, I have 2 log lines, like with a 10-second difference, and one said that it will have 1.7 terabyte storage, another one say that only 90 gigabyte storage. And it is really weird.
Interesting. Yeah. Are you sure that they're within the same like EC2 node class as well?
Yeah, exactly. Exact same node class, exact same availability zone, exact same instance type.
Gotcha. Okay. And the instance store policy specifically, I'm not familiar with what specifically the instance store policy is.
Yeah, it is a new feature with if you enable this stuff, so you will tell Karpenter, I will use local NVMe storage as an ephemeral storage for my pods.
Yeah, it would be. I off the top of my head, I don't know what might be going on here. It'd be good to have some sort of issue so that we can see if there's maybe part of the log lines that are important here that we haven't talked about. Would that be useful for you if you could open up an issue and we can talk about it through there?
Yeah, we added details to pull request. I think, yeah, probably is worst open new issue. I mean, pull
Oh, it's
request,
in a
we had
pull
a
request
feature
right now?
enabled. No, it is merged pull request for instance store policy feature.
Hey, Nick, I know this is something Jonathan spent some time looking at. He has actually some internal like analysis doc that we can look at.
Gotcha. Yeah, I think then I know Jonathan's out of the office today, so definitely would
Yeah, no
be
worries.
helpful to get his opinion on that through an issue, like a hit issue. All right. Yeah, I don't see any more community questions or RFCs. Is there anyone else who'd like to ask a question that they didn't want to put in the doc?
Yeah, I can ask another quick question about Drift. So somewhere in the document, migration document, I spotted that, mentioned that Drift will not be optional after few release. So currently we are baking image quite frequently. This means that we will have to recycle all our nodes when we have new image, because AMI selector will detect new AMI in AWS sites, and it will mark all our existing nodes as drifted, right? So your current decision about Drift, so Drift will be part of Karpenter, so we can't disable that feature. Is my
So you can
understanding
actually,
correct?
yeah, you should, I believe you're talking about node pools on version 33 and over. So Drift will just be enabled by default, but you can still disable Drift globally if you'd like.
Yeah. Currently, it is possible to disable, but in some blog post in AWS site, so I think it was related alpha migration. So there was mentioned that so Drift will be part of Karpenter, and you will not able to disable at some point.
Yeah, you should still be able to disable it. I don't know which blog post specifically was that, but we are adding a new control on top of node pools as well that might be helpful for you. So right now, so we just added disruption budgets in version 34, so you can control when you want to get disruption. But there is Bryce on the Azure side who's working on adding a per reason budget. So when that gets merged and released, you could add in a way to say, I don't want any of my nodes to be drifted ever. That's something that you could do per node pool as well.
Yeah, got it. I'll just try to find the blog post and we'll share here.
That raises an interesting question, right? So right now, in the disruption spec, you can say when underutilized or when expired or empty, sorry, but you might want to explicitly turn off something. The first place I would look is not the disruption budget. Like if I want to turn off one of the ways to disrupt nodes, I wouldn't look at the disruption budget and be like, don't give that that specific thing any budget. I just want to turn it off. Is there a way to expose each of the disruption methods and say like yes or no, or is that like something we don't want to expose and we want to rely on something else? Like, I guess from a user perspective, like budget seems to I'm getting too deep to turn off something. Is there something higher level that's more obvious? Like I don't want this to happen, turn it off, if that makes sense.
Yeah, I think that's a good question. So we've actually thought about this in the perspective of the termination grace period seconds as well. Is that we currently have some of these disruption methods or disruption settings enabled on the node pool when theoretically you might just want it set on the node claim itself. So like the expire after or like the max node lifetime, that might be something that you want to put on the node claim. And then consolidation, like we would want to be on the node pool because you can do some batchings of nodes on a node pool. So it likely doesn't make sense to put it on the node claim. The one that we've heard the most often was Drift, like you're asking and kind of leading towards too. And so I personally think of Drift as, or I would think of Drift and kind of liken it to deployments like rollout strategy here. And the fact that Drift for deployments and replica sets is just how it works in Kubernetes. And if you want to be able to pause a deployment or roll a deployment or change how that pod change is rolled out, then that's something that you can add into your deployment setting as well, which I think is kind of similar to disruption budgets in that you can control the speed in which it happens, and adding in that additional drift reason into disruption budgets is kind of a step past what deployments allow you to do, which is to say, I don't want this actually to get rolled at all, which we could argue maybe we don't want to do it. Maybe we just want to say that people should have to control it through the disruption budgets and their do not disrupt pods or some other sort of override control.
I guess from a high level perspective, like let's say I don't want rolling updates, right? Like it's a change that Drift right now relies purely on rolling updates. But let's say I want to do blue-green instead, right? Like there's no mechanism for me short of never drift through disruptor budget, make a new node pool with a new pointer to a new node class that has a new AMI, and I simply make that come up and then like shift traffic over kind of thing. Like there's no easy mechanism to do blue-green. I don't know how often this happens. I guess this is a question of like, do people need this? But if we do, like the mechanics of doing it is kind of hard right now to do. I'm not sure how much value there is. It raises a question of like, in the case that drift doesn't work for me because of the way it rolls out, there isn't you're going against the grain in a way to get it to work in a different way. That makes sense. And I feel like blue-green is somewhat common to have, but I don't know. Yeah.
Yeah, I think one of the ways that we were tackling node upgrades and Drift especially is to kind of understand at a core like what Karpenter can do and what would make it prone to some other errors. So one of the things that I thought about when I was designing this is that blue-green deployments is definitely something that a lot of people like to do, but it is a very stateful operation. And deployments and other kind of management systems are able to do this because there's a set number of replicas and there's a set like template that you can follow by. Whereas Karpenter, it's a very dynamic way of understanding if we need to spin up a new node or just delete the existing nodes.
Mhm.
And so it's effectively just a look at the pods in my cluster, look at the pods on these nodes that are being deleted, and look at the pods that I want to delete, and see if there's room in the cluster for that. If not, create a new node. And so at the moment, right now, it's a per node, like max surge of 100% rollout, where we always spin up a replacement if it's needed. We wait for it to be ready, and then we deprovision the old one. But I can totally imagine there's like other deprovisioning controls that people would want to have for their upgrades that I think I'd rather push us towards understanding what are some of the use cases there to know what controls we need to add in. So that might look like some sort of cooldown, which we've heard that people want, which is like after I disrupt a node, I actually don't want this to be another node to be disrupted for another like 15 minutes because maybe I have a that I want to test out in my cluster and I don't want to have that image potentially be faulty and then roll out and then kind of take out the cluster. So some people have asked for having some sort of cooldown there. And then disruption budgets is kind of a way to allow some sort of max surge to allow like a certain number of nodes to be disrupted at one point. But currently there's our internal concept of a disruption command, which is a set of nodes that we want to disrupt and a set of nodes that we want to replace with those nodes. And you can imagine there's other controls people might want to do to control that.
That makes sense.
It would be really cool to know like how you're thinking about upgrades as well, and to know if there's other stuff that we're not doing that you want to do. I know that you added the finalizer RC some bit ago that has some details that we might want to include, but I want to tackle like a specific or like have like a list that maybe people can +1 and say that this is how they think about upgrades and how maybe Karpenter's not working perfectly for them.
Yeah, I can give this some thought and generate an issue or something that kind of talks about what we're thinking about and maybe what Karpenter doesn't do. But I don't have it fully shaped right now. Yeah.
Nick, by the way, I just sent the link in the chat. So it says this feature gate is expected to be fully dropped when Core API are bumped to version 1. So if it's final decision, so we will have to start some work on our side to change our AMI release strategy, probably.
Yeah, I'm trying to find.
Just
Okay,
search
this
drift
one.
enabled by default. Oh yeah.
Yeah. So this is what I think this is what we were thinking about doing for V1. I'm not sure if you're here for the beginning of the meeting, but we do have a laundry list here that describes all the things that we wanted to do before going to V1. So I'd recommend adding your thoughts and use cases on specifically being able to disable or enable drift by globally.
Yeah, sure. Thank you. Yeah, I just joined a bit later, so I will catch it. Thank you.
Sure. Yeah. All right, cool. We have 8 minutes left. Is there any other questions from anyone? All righty. Thanks for showing up, everyone. Have a good day or good night or whatever you're doing.
Thanks, Nick.
Yeah,
Thanks.
happy Monday. Bye-bye.
See you, everyone.